all this, the only thing this slide does is it defines a function called main. It defines it, doesn't call it or anything. Within main, it will ask me for a monthly investment. It will ask me for yearly interest rate. It will ask me for number of years. And then down here, we're going to get in trouble because we're going to call this, which is not defined. Okay, so this calculate future value, we'll add that, I guess, in the next slide, uses all of those values that we entered up here, and it would call, there should be a function here. Let me show you. And so if we run this, again, nothing happens. All we did was load main into memory. So if I say, where is main? You get this byte code stuff. But if I call main, you got to have the parentheses to do that. It will faithfully ask me for a monthly investment, faithfully ask me for a yearly interest rate, faithfully ask me for a number of years. But then we get into trouble because name error, I'm calling this, right? I'm calling this function here that's not defined on this page. Okay, so this is where the error comes in. Okay, well, why would we do what's the contribution here? Well, a program, you're going to have lots of functions in a program, and you want to control the flow. And that's the purpose, one of the purposes of the main function. So let's extend this, and we'll include that naughty calculate future value. No, we won't yet. What does this next slide demonstrate? This next slide, notice when we did this, I had to call main. When I ran this little bit of code, it loaded main into memory, but in order to get main to run, I had to call it in the interactive shell. Okay, well, is there a way to get around that? And there is. Let's say you have a main function and you have all these other functions that are called by main. If you put this little snippet of code in there, and Muroc really doesn't explain what it does. Here, this is what he says. When all of the code of a program is divided into specific functions in the main function, you need to have some mechanism to call the main function to start the program. What this little snippet of code will do is, if it's usually at the very bottom, and it will, when the program compiles, it will run this first. If it sees this if underscore name underscore equals this, it will call it. Okay, this is just an if statement. Okay, but it runs immediately and it calls main, and so then main gets called and does all of its stuff. This is one way. Python sets its internal name variable to the value of this. And you can use an if statement, just like we see here, if, to check whether whether there is a main, and if so, it'll run it. Okay, if this is confusing, and it really shouldn't be, don't worry about it. Just make sure you have this little piece of code. I like to call this magic. This is the magic piece of code that you have at the bottom. Of course, you don't have to have these comments. That's just telling you what it does. Okay, so that's that. So let's go over here to the future value program, and we've got this one. And I know we've seen it before in some carnation. I'm not sure if it's the exact same program, but we can open that. we've got quite a few programs today. Notice what we have, right? You can see it all on this one screen. We have the definition of calculate future value. This is a simple program. It's just got two functions, calculate future value and then main. And main gets called because we have this magic snippet of code down here, this if statement that sets the name variable to main. So this gets called right away, and that in turn calls this. Well, what does this do? Well, choice, again, we see this while statement to control the execution of whether we want to do it over and over again. Instead of initializing variables at the top, which would be, well, no, you can't do that actually. These are local variables, so they're defined within main. It will, let's run it. It'll ask me for this, it'll ask me for this, the years. Then, unlike that other one that blew up, it will call this, which is up here. And it will pass those values into this function, which will calculate the future value. Okay, so it's a, an extension. It's a little more than what we had before. So we say $500 a month. We say yearly interest rate 12%, which seems usurious in 2023, but it was a bargain in what, 1986 maybe. Number of years, say 10. And we get this unformatted dollar value. And then we can say, do you want to continue or not? Okay, so we'll say, okay, we'll do it one more time just for, let's do half as much, 250, 12, 10. And I think if you find this is half of this, right, it should be. And so now I say, do you want to continue? I say no. Well, what's going on here? Well, we can show this on the slides. Here's the interface, and I didn't use the same values. This is the calculate future value. I like to use the slides sometimes to demonstrate code because he color codes in yellow the important parts of it, I guess, which is the definition. Here's the name of the function and the operative arguments, and they're the defined names. And then this is all right. You enter a yearly interest rate, so you have to divide that by 12 to get the monthly interest rate, and by 100 if you want a percentage. And to get months, you have to take years and multiply by 12. And then this calculates future value using a for statement for I in the range of months. And if you have 5 years, it's 60 months. Notice it's using these compound, what the Murrah calls, I think, compound operators. I call them incremental operators, where it's actually adding this to this tally, to this ongoing value for this. And it's doing that here too. And here it's just multiplying those two. Return, again, returns a keyword, and whatever this value is will get output by this function. So that's what that does. And again, main, rest of the program, main, there's not a whole lot I can say about that. We have this similar, this prototypical way to allow the user to continue or not with this while statement controlled by choice, which is probably on the next slide. Yeah, it's at the bottom of main, right? This, if choice is always Y, it will go through this again and again and again, allowing the user to keep entering in different numbers and getting a different calculation. And then it prints everything out here, I guess, right? So, but this is still part of the program. Okay, so that's pretty, that's not so bad. This again calls it all. Calls main, which calls calculate future value function. Okay, well, so what else can we do? Well, when you define a function, and this is almost always done with functions of any complexity at all, you'll have arguments in there that already have default values, like this one. Okay, so which you can override when you call it. Well, why would you want to define a function that has an argument that has a default value? Well, when you start looking at the definitions of these functions, you'll find that many of them have a dozen or more arguments. And, if you're the poor SAP user who's got to call these things, you don't want to be passing 12 different values, figuring out what they should be. First of all, understanding what all the arguments are. So in order to avoid that scenario where using the functions is very user unfriendly, because you have to give a value for perhaps dozens and dozens of arguments, the author of the function will just have one or two, not undefined, one or two arguments that do not have default values that you have to enter something for. In this case, it's these two. But all the ones after that, and there could be lots of them, will have a hardwired value, a default value. So you don't even have to call it. You can call it calculate future value. You can leave it out. You can forget about it, and it'll still be years will still be passed into the function with a value of 20. I could call this function calculate future value with only these two arguments, and it would still work because it has a default value of 20. Or I could call it with all three, and I could change the value for years. I could say years equals something else, 10 or 30 or 40, and that will override what this is. Okay, so when you do this, the arguments without the default values by protocol, it's not strictly necessary, but just by practice, by best practices, the ones with default values come last. It doesn't have to be that way. I could define this function and put years equals 20 first, but it's good programming practice not to do that, so that when somebody calls it, all they have to do is put in these two. Here, let's see this. This is on a script. This is on a slide. I mean, on a script. So let's find this. This is number 11. And there aren't, as I mentioned before, there aren't that many. So if I run this, it will, let's see, it should output once I run. Okay, so we load this into memory, and let's see if I can do this without messing it up. Monthly invest, yearly interest. Okay, so all it did was load the function into memory. So let's see, I'm going to call it, I'm going to say calculate future value. And I'm not going to use the named arguments, the formal named arguments. Those are in the definition, the function definition. I'm just going to say something short, month invest, and this should work. This is monthly investment, and I'll say, I don't know, 100, and then comma, and then year. I'll be real sloppy, and I'll just say year int for year interest rate equals 10. And notice, because it's in memory, it gives me these little helper snippets, right? It's telling me what I'm supposed to be putting in there.